हरिः कर्ता।
So Prasad has reached so far. So he understood a lot of concepts regarding association rule mining. So while he got a doubt, whatever whatever he has understood, it seems a probabilistic things to him. It sounds like probability. So that's the reason he just want to deep dive into each and every thing that he has learned so far, and is trying to connect with probability and just to confirm these things, whatever it could be support or confidence. Are they probabilistic terms, or they probability related ones? Are they probability? And that's what you just want to explore. Let's see what's going to happen. So let's begin with support. Obviously, all support confidence, and left all these metrics are rule evaluation metrics to assess the strength and significance of an association rule. So we can use this support, confidence, and left. So let's begin with support. So support is a measure that tells us how frequently a particular item set or association rule appears in the transactions recorded by Prasad, a shopkeeper. In our grocery store context, support measures the fraction or percentage of transactions that contain a specific item set or association rule. So it helps Prasad identify the popularity or prevalence of certain item sets or rules among all the transactions. So these are the two fundamental outcomes using support. So so if Prasad uses the support metric and apply to his data, so what he can identify is the popularity or prevalence of certain items or rules among all the transactions. So for example, if Prasad calculates the support for the association rule that we have discussed earlier, that milk diaper to the beer, so what exactly happens? Let's see. But before that, does it does not it sound like it's a probability? Mathematically, support is probability of an item set. Let's see. Let's take an event, an item set. X is an item set and we can call it as an event. So capital X is equals to milk, bread, diaper. So this is our item set. So now support of X. Normally, that's how we represent it. In spite of that, we can also share it as a probability of X is equal to a count of item set occurrence, the occurrence of this item set divided by total transactions, and that's what is probability for us. So support count for this is bread, milk, bread, diaper. So milk, bread, diaper, milk, bread, diaper, we got 2, and total transactions are 5. Hence it's 2 divided by 5. So fundamentally, support is nothing but the probability calculation of your item set. One metric is done. Now let's look into the other one. So confidence. So confidence is a measure that quantifies the reliability or strength of an association rule. It tells us how often the items in the consequent Y of the rule appear in the transactions that already contain the antecedent X of the rule. In simpler terms, the confidence measures the likelihood of finding the consequent items given the presence of the antecedent items. It sounds similar to something as it is a conditional probability of an item sets. So mathematically, confidence is a conditional probability of an item sets. Let's take this example. Let's take this association rule. So milk, a diaper, that is our item set X, and beer is Y. So we have two item sets which is X tends to Y, and that is our association rule. So buying a milk and diaper together can tend to buying beer, and that's this association rule can be represented as X tend to Y. Done. Now, so to calculate the confidence of X tend to Y, what we have to do is we can also say that probability of Y given that X has occurred. Let's see that. So this is what we calculate, and this is how we calculate. So this can be written as probability of X and Y divided by just probability of X. Now let's try to calculate the probability of X and Y. So probability of X and Y, let's find how many transactions that we have where the customer buys milk, diaper, beer all together. Let's see. So milk, diaper, and beer all together. So 1, 2. So it's 2, and probability of X obviously only milk and diaper. This is 3. It should be that. And this can also be written as support. This can be written as this way, or this can be written as this way, but we normally follow this. But the fundamentally this is probability. Okay, so probability, the support of milk, diaper, beer, that's 2 divided by 5, and the support of milk, diaper, so that's a 3 divided by 5, and 5 gets cancelled, and 2 divided by 3, which is 0.67, and it tells the same. Confidence is conditional probability of an item sets. That's it. And the third metric, which is lift. Third one is lift. So lift is a metric used to determine the strength of association between the antecedent and consequent items in an association rule, taking into account the background support for these items. So lift helps Prasad understand whether the occurrence of the consequent items is dependent on the presence of the antecedent items beyond what would be expected by chance. So let's mathematically, lift is a Bayesian probability of an item sets, and so lift can be calculated this way, which is probability of Y given X has occurred, all divided by probability of Y. So if you put it in association rule mining terms or terminology, confidence of X tend to Y divided by support of Y, and this is how we calculate a lift. So a lift value greater than 1 indicates a positive association, suggesting that the presence of the antecedent items increases the likelihood of finding the consequent items. A lift value equal to 1 suggests independence, meaning that the presence of the antecedent items does not affect the occurrence of the consequent items. A lift value less than 1 indicates a negative association, implying that the presence of the antecedent items reduces the likelihood of finding the consequent items. So Prasad can use lift as a guiding metric to identify association rules with meaningful relationships. A lift value greater than 1 signifies a potentially interesting rule where the presence of a certain items in a transaction positively influences the presence of the other items. So in Prasad's grocery store, support helps him identify the frequency of occurrence of item sets or association rules, which is nothing but the probability of the item set. Confidence helps him measure the reliability of these rules, which is nothing but the conditional probability of the item sets. And lift provides insights into the strength and dependency of the associations, which is nothing but is closer to the Bayesian theory. So Prasad can, by analyzing these metrics, Prasad can make informed decisions to optimize his store layout, promotions, and product recommendations, ensuring a better shopping experience for his customers.